Ryan Reynolds here from Mint Mobile. With the price of just about everything going up during inflation, we thought we'd bring our prices down. So to help us, we brought in a reverse auctioneer, which is apparently a thing.
Mint Mobile Unlimited Premium Wireless. How to get 30, 30, bit to get 30, bit to get 20, 20, 20, bit to get 20, 20, bit to get 15, 15, 15, 15, just $15 a month? Sold!
Give it a try at mintmobile.com/switch.
$45 up front for 3 months plus taxes and fees. Promo rate for new customers for limited time. Unlimited more than 40 gigabytes per month. Slows full terms at mintmobile.com.
With threats to our nation waiting around every corner, adaptability is more important than ever. When conditions change without notice, quick strategic thinking is crucial. And with obstacles consistently impending, determination is essential in overcoming them. It's this willingness, decisiveness, and resilience that sets Marines apart. With our fighting spirit, we don't just fight battles, we win them. Marines are the constant our nation counts on to fight the unknown. And through adaptable problem solving, we do just that. Learn more at marines.com.
Hey everybody, welcome to the Single Tracks Podcast. My name is Jeff, and today my guest is Colin Ryan. Colin is a senior development engineer at Norco, and he was involved in the design of the latest Norco Optic trail bike, which features a high pivot design. Prior to joining Norco, he worked at General Kinetics, testing and developing shock absorbers for military and construction equipment. Thanks for joining me, Colin.
Yeah, thanks very much, Jeff, for having me.
So we're going to be talking about high pivot designs and high pivot bikes. And obviously this is like kind of a new thing that's trending within the mountain bike world. A lot of people have questions about it. So let's start off talking about high pivots at a basic level. What problem does a high pivot design actually solve for mountain bikers?
Yeah, so I mean, I guess to start off, we at Norco we've got years of developing various different designs that would fall under that kind of high pivot class. And so we kind of actually like to think of high pivot bikes, not so much as like black and white, this is a high pivot bike or it's not, but more as a spectrum.
Okay.
And really what we're trying to do is have better control over the axle path of the rear suspension and allow the rear axle to move a certain amount rearward as it moves through its travel. And that's typically what gets associated with the high pivot kind of term. And normally people associate that with an idler. And the idler, in most cases, comes along with more rearward axle path, but not always. And I guess in terms of the problem that we're trying to solve is we're focusing on controlling the axle path to match the type of terrain that the bike is designed around. So you can imagine if your rear wheel encounters an obstacle in the trail, depending on how large that obstacle is, the force that it actually creates at your rear wheel isn't purely vertical. There's a horizontal component as well. And what we're trying to do is allow the rear wheel to move backward in response to that force. So translate that force into suspension motion and less of that force acting on the front triangle and the rider. And ultimately that has a feel of a bike that carries momentum through rough terrain.
I see.
Without kind of hanging you up on those sort of square edge hits.
Right.
And the reason we think of axle path as a spectrum is you can tune how rearward the axle moves through its travel to kind of suit the terrain. So as the terrain gets rougher, our thinking is that you need more rearward axle path to manage those larger square edge hits. But there is kind of a middle ground, and that's kind of what we've looked to strike with the sight and the optic, where you can benefit from a certain amount of rearward axle path, but the terrain's maybe not quite as aggressive as something like a full-on, enduro or downhill race bike. And so you can kind of find a middle ground that gives you a bit of the best of both worlds.
Yeah. And how do you do that? That's interesting because I haven't thought about the high pivot design as being on like a spectrum. Like are we saying that some high pivot bikes have like a higher pivot, or like what can you adjust that does allow it to like be on a spectrum?
So I guess there's kind of two maybe categories of high pivot bikes. So a lot of the early designs that you would see, even over 10 years ago, really, these bikes have been around, but most of them were what you'd call a high single pivot design.
Okay.
So the rear axle's mounted to a swing arm. That swing arm's directly connected to the front triangle. and your axle path rotates about a constant arc, and that's just defined by the location of the main pivot. And so the way to get more axle path out of those bikes is just to move the main pivot higher on the front triangle.
Okay.
What we found through testing, I mean, that's what our Orem HSP was. And what we found through testing with that bike is we learned some things about axle path, but we also learned some things about high single pivots and what they maybe don't do so well. And most of that has to do with their performance under braking.
Okay.
You get a high interaction between braking force and suspension. And so more recently, you'll see us and other brands moving towards virtual pivot bikes that have a certain amount of rearward axle path. And with a virtual pivot bike, the rear axle carrying link isn't directly connected to the front triangle. You have two typically connecting links. And those two connecting links define what we call a virtual pivot point or an instant center. And that instant center is the point the rear axle rotates about. So it sounds complicated. It's not when you kind of draw it out. But really, all we're trying to control is the point that the rear axle rotates about, and the height of that point relative to the rear axle is kind of what dictates how much rearward axle path you get.
Okay.
So when I talk about it being a spectrum, really with the sight and the optic, we'll locate that virtual pivot point at a height that's not quite as high as something like the range. And as a result, the range has a certain amount of rearward axle path, and the sights are kind of somewhere in between what you get from the range and what you might get from something like our fluid.
Okay. So let me see if I'm understanding this correctly, because like you said, it is complicated, or at least it sounds complicated on a podcast anyway, right? Like we don't have models and diagrams to look at here, but it sounds like maybe, if we go back 5 or 10 years and look at mountain bikes that were using a high pivot design, for starters, they were almost all long travel bikes, right? Like they were downhill bikes in general. And were they all single pivot? Like, is this what's kind of different now, is that this has been something that's been used on single pivot to kind of like eliminate some of the drawbacks or limitations of single pivot? Is that fair to say?
Yeah, I mean, it's definitely moving to these like virtual pivot layouts with some rearward axle path is a more recent trend. I don't want to say there's other examples going 5+ years back of designs that used a virtual pivot layout to get a rearward axle path, but it's definitely a more common thing to see that these days. And you see brands like ourselves and others that used to have high single pivot designs in the lineup and now moving towards these high virtual pivot layouts that give you a bit more control over different kinematic traits. Okay.
And so then, now it's also sounding like these are two distinctions. Like is a high pivot different than a virtual pivot? Like are we talking about two different things, or like two different styles of high pivot or implementations?
I guess high pivot's usually used as kind of like the blanket term for bikes that have a certain amount of rearward axle path. And I think really most people, because it's a visual thing, they see the idler and go, that's a high pivot bike. But I like to think of it like the idler comes along generally when you start to have a certain amount of rearward axle path or a certain amount of chain growth. But like I said, it's a bit of a spectrum. So there's sort of a point where the chain growth that you get as the rear axle moves away from the bottom bracket becomes too disruptive. It'll create too much feedback through the rider's feet. And then you start to introduce an idler to manage that chain growth. And I think that's the point where people associate them as high pivot bikes.
Right. Gotcha. So obviously there are reasons to go to a high pivot design. What are some of the drawbacks to this? Like, why don't we just see this on every full suspension mountain bike out there?
Yeah, so I think typically people see the idler on the bike, depending on the implementation, visually the bike can just look more complicated. And so people, sometimes are just put off by that visual complexity. It's fair to say that when you add an idler into your drivetrain, it's another component that the chain has to rotate around. And depending on how you've located the idler, your chain angle, and the size of the idler, it'll introduce a small amount of additional drag as the links have to kind of articulate around the idler. We've put a bunch of time, especially in these most recent bikes, into understanding this better and understanding the ways in which we can mitigate those things like inefficient or perceived inefficiency from the drivetrain, but then also noise and vibration that sometimes can be either heard or felt through the rider's feet on a high pivot bike. So those are all things that we've learned through several generations of doing bikes with idlers. And I think on these most recent ones, we've come a long way in terms of improving the pedaling feel to the point where I kind of forget that the idler's there when I'm riding a sight or an optic.
Interesting. I think of all those things that you mentioned too, I mean, I'm sure people use those as like reasons why that's, they're not interested or they think it's a bad design. But I think the first one you said, the visual, for a lot of people, it's like, that's it. Like, that's just the reason. And they're not able to get past that, which is, I don't know, a lot of things, it can be unfortunate. Like we ride bikes that maybe don't fit as well as they should because we want it to look good, or there's lots of things we do just to make sure our bikes look cool that maybe aren't worth doing.
Yeah, I mean, I will say credit to our industrial designers on the site and the optic. I think we recognize that for these bikes to be more mainstream and be kind of the core of our trail and all mountain lineup, they needed to look less out there. And so our industrial designers were kind of challenged with find a way to integrate this idler in a way that's less or more visually appealing, or less complex or less intimidating. And I think they did a really good job. It's kind of packaged inside this pocket in the chainstay. It's the idler itself. You actually can't really see all that much. And it's just much more nicely integrated than maybe what we've done in the past. So I think that certainly helps with the look of the bikes. And to me, they look pretty conventional, really. Yeah.
So one of the advantages that I've heard or maybe read about with high pivot designs is that the design improves longevity. And I'm interested, like, is that longevity for the drivetrain or the suspension or both? Like, how does a high pivot design improve longevity for a mountain bike?
Yeah, the drivetrain one's not something I've heard. I mean, to us, the drivetrains, the wear is really the same as it is on a conventional drivetrain. We can touch on that a little bit later when we talk about the idler development we've done. But to me, the longevity maybe comes your wheels. Probably your rear wheels probably going to have more longevity.
Oh, the wheels. Yeah.
Generally, we see high pivot bikes tend to be a bit easier on wheels, especially in like really rough terrain. And that comes back to how you're managing the force through the rear wheel. So if you're allowing more of that force at the rear wheel to translate into suspension movement. And that's the purpose of suspension, is to manage force and the energy that's going into the bike as you run through rough stuff at high speed. It's easier on other components that aren't necessarily as good at managing that energy. So definitely these bikes, we see, they're easier on rear wheels. The other longevity part that maybe I'd mentioned that's not necessarily bike related, but is more rider related, is just the reduced fatigue that you have when you're riding rough trails at high speed. Same thing, comes back to more of that force translating into motion of the suspension and less of it getting transmitted to you, the rider. And as a result, the bikes are just less fatiguing to run over long descents.
Yeah. So it's longevity for our bodies and for our energy. Also, with the rear wheel, I assume too, that's easier on tires a little bit. And I mean, have you found you can run like slightly lower rear tire pressure based on that, like having those reduced impacts in the rear wheel?
I don't know if I've personally found that. I generally have kind of run the same tire combo and same pressures with these bikes as I did on the last generation, but I personally don't run inserts. I've never had issues with rear wheel durability especially on these new bikes. And I know there's quite a few people that tend to put an insert in, not necessarily because they like the feel that it adds, but they want to protect that expensive wheel set that they bought. And this would potentially be a way to not kind of need that insert. You can ditch a bit of rotational weight, but you're still feel confident that your wheels are going to be protected. So,
interesting. Yeah, that's an interesting side benefit for sure. One of the things that I think people are curious about as far as the drivetrain goes is the amount of chain wrap that you see on a high pivot design. So with less chain wrap on the crank, are drop chains an issue with a high pivot setup? And if so, like, do is a tensioner usually something that people see on these types of bikes?
Yeah, I guess there's a couple things to mention on that. So when we first developed the range, we didn't have any kind of lower guide on the chainring. Mm-hmm. And we wouldn't necessarily notice that we would drop chains with a brand new chainring. Mm-hmm. But what we did notice is after a certain amount of use, we started dropping chains under load. And when we looked into it, we realized we'd have this really uneven wear pattern on the chainring. Uh-huh. And it came back to, depending on which foot you ride forward with, the teeth that are kind of engaged with the lower span of the chain. Mm-hmm. So from derailleur to chainring, were wearing prematurely when the rest of the teeth on the ring were fine. Yeah. And so that had to do with the amount that the cage of the rear derailleur swings and then kind of creates a chain wave that wraps and unwraps those teeth. And over time, especially if it's an aluminum ring with a steel chain, mm-hmm. it'll round those teeth off. And then when they round off, you get to a point where it starts to drop the chain under load. Mm-hmm. So that was an early learning for us on the range, which has quite a bit more rearward axle path. But we solved that by adding a guide from MRP that's a non-contacting guide, but it basically acts as a shelf to prevent the chain from unwrapping the chainring in those instances. Okay. And once we added that, we didn't have issues with chainring wear or chain drops. And so we carried that learning over to the site in the Optic, but we ended up doing our own custom guide that's tailored around the bikes and is a little bit more adjustable for different ring sizes. But basically, it just acts as a shelf to not necessarily increase chainring wrap, because that's never really been an issue. Mm-hmm. It's more to make sure that chain doesn't slap around and wear the teeth on the chainring, and that's ultimately what we found can sometimes cause chain derailment. I guess we were going to get into idler stuff as well. I can maybe mention the guiding on the idler is another learning for us over a couple of generations of bikes. Admittedly, in the past, we've had guides that weren't as successful as they needed to be at maintaining the chain on the idler. Mm-hmm. So we've learned from that. We did a big project, Adrian and Kirk, two of the other development engineers at Norco. I really dug into understanding what causes the chain to derail off the idler and how we can prevent that. And so on the new site in Optic, the ways we've solved that issue are reducing the rate at which the idler wears by moving to a stainless steel idler with a diamond-like carbon coating. Mm-hmm. One of their findings was as the idler wears, it gets thinner. As the idler gets thinner, it gives more space for the chain to derail between whatever guide you have and the idler itself. Mm-hmm. And then they really looked at where do the guiding surfaces need to be around the idler to prevent the chain from derailing. So that's another place where we've really put effort in. And between the idler guide and this lower guide on the chain around the chainring, the bikes have been really, really good for not having chain drops. And I guess the last point to mention is the nice thing is by not needing to run a lower roller guide, you're eliminating another component that the chain needs to interact with. Right. So again, if people are a bit intimidated around the drag thing, adding another lower roller that introduces a bit of drag is something we wanted to avoid. And we've been able to do that with this guide that we're using.
Yeah. It's fascinating, all the things that are learned along the way with these designs. Like, man, whoever figured out that like your lead foot will determine like how this wear is happening, like, that's pretty impressive. I'd be excited if I figured that out. Like, oh, this guy's leading with his left, or this guy's leading with his right, and I can see it in the way that the crank is wearing. That's pretty impressive.
Yeah, that one was pretty cool to find out. It took me almost breaking my ankle a couple times when the chain skipped under load to realize what was going on. But yeah, it was cool once we figured that out. And definitely, I mean, the most satisfying thing I think is when you figure out what the root cause of the problem is, and then, you implement design that solves it. You complete the loop really, and that's the most satisfying part.
Yeah. Or I guess what if somebody rides switchfoot? Did they not have the problem, like where it was wearing it the same both ways, or no more testing?
Once we kind of had that theory, we would have somebody that rode opposite foot forward to myself or one of the other testers just to confirm, and then you would see the same same type of wear, but on the opposite side of the ring. And that's kind of how we would that's how it clicked in our heads that, oh, okay, it's to do with descending, which is weird because, you know, most times you think your drivetrain's really only wearing when you're pedaling, but in this instance is a bit different.
Yeah. And then on the idler itself, is that using like a narrow wide tooth profile or is it just more like a derailleur cog would be?
Yeah, we looked at both options. So narrow wide from in terms of keeping the chain on the idler seemed like the preferred way to go. And so I think initially we thought that's the direction we would go. But then coming back to this sort of priority to reduce vibration and noise through the drivetrain and really make these bikes pedal as if they didn't have idlers, we realized once we started testing these narrow wide idlers that they actually introduce some additional noise and vibration.
Yeah.
And so then that's kind of what drove us to look at other ways to eliminate chain drops off the idler that didn't require us to run a narrow wide idler. And so on these bikes, they're just standard narrow, I guess, similar to what you would have on some derailleur pulleys. And there was some work that we did on tooth profiles, but that was more focused on, again, like trying to reduce vibration and harshness, and really the learning that Kirk and Adrian brought over from their testing on idler wear and guiding solved the problem of keeping the chain on the idler. So we could just focus on the design of the idler around reducing vibration and harshness through the drivetrain and try and make it pedal as normal as possible.
I see. Yeah. While we're talking about the idler, does the number of teeth play into this at all? And like, does it depend on what size crank you're running?
So the size of the idler there's, I guess, a couple benefits to tuning idler size. So in terms of the drivetrain feel, the larger idler means that the chain links don't need to articulate by as much when they rotate around the idler.
Okay. And
so that can help with some of the efficiency. There is a point where we're running some fairly large idlers on the downhill bike. Some of that's more to do with kinematics that we can touch on later, but there's a point we found where packaging that larger idler becomes a bit difficult on these trail bikes. So we settled on an 18 tooth idler as kind of a nice middle ground that could be packaged. It didn't add additional weight by needing, a large area around the idler on the chainstay. But at the same time, it was large enough that when we compared it to 16 tooth idlers that we'd run in the past, you get a much better pedaling feel out of an 18 tooth idler. So that's kind of how we arrived at that size. We've tested larger than that on the range and the downhill bike, but yeah, it didn't quite make sense for packaging reasons on the trail bikes.
Interesting. Maybe we've kind of touched on this, but how does the placement of the idler in terms of like how high or low it is on the bike, how does that affect performance?
So the location of the idler is something that we really dug into on the sights and the optics. Previously on the range and the shore, the idlers are mounted what we call concentric to the main pivot.
Okay.
So they're just mounted on the shaft of the main pivot hardware. And that was one thing, I think with those bikes being more biased towards descending performance, we could live with the trade-offs of that in terms of how they pedaled. But I kind of felt going into this project with the sight and especially the optic, for people to really buy into this bike as being like a proper short travel trail bike, it needed to pedal exceptionally. And so I felt we needed better control over the anti-squat characteristics of those bikes independently of where the main pivot was located. And when we started getting into that, because the sight and the optic we call it a VPS HP layout, but it's a high pivot horse link design. So the idler is mounted to the chainstay and the rear axle is mounted to the seat stay. Because those two are mounted to two separate links, they fall under a patent from a company called iTrack. And we went into a licensing agreement with iTrack for these bikes because we felt that being able to tune the anti-squat characteristics of the bike by moving the idler's location was so important to achieving the pedaling characteristics that we wanted.
Yeah.
And so the way that the you can tune anti-squat with idler location is there's kind of two forces that make up how much anti-squat you get out of a suspension layout. Anti-squat is just how the suspension responds to counter weight transfer to the rear wheel when you accelerate. Mm-hmm. And one of those forces is just how much acceleration force you develop at the rear contact patch where the rear tire meets the ground. Mm-hmm. But the other force is the force that the chain applies at the cassette. And the angle of that force relative to your kinematic points plays into how much anti-squat you get out of a suspension layout. And so that's what you're tuning with the idler's location, is you're changing the angle of that chain force relative to the kinematic points. And you can use that to give you more or less anti-squat. And the really nice thing about that you can't get out of any other suspension design is you can tune anti-squat independently of other suspension characteristics. So on a bike that wouldn't run an idler, let's say just a standard horse link bike or something, if I try and tune the anti-squat characteristics of that bike, I'm going to do that by likely moving the main pivot or potentially the horse pivot around. And when I do that, I'm affecting axle path, I'm affecting my leverage curve, anti-rise a little bit. So you kind of, everything's a balance. But with these designs and being able to locate the idler in the way that we're doing it, we can tune anti-squat independently and not affect any of those other characteristics. So it's not a super obvious benefit, which is why I like talking about it, but it's a really unique benefit to this type of design.
Hey, it's Kaylee Cuoco for Priceline. Ready to go to your happy place for a happy price? Well, why didn't you say so? Just download the Priceline app right now and save up to 60% on hotels. So whether it's Cousin Kevin's Kazoo Concert in Kansas City, go Kevin, or Becky's Bachelorette Bash in Bermuda, you never have to miss a trip ever again. So download the Priceline app today. Your savings are waiting.
Go to your happy place for a happy price. Go to your happy price, Priceline.
Think you know the Brooks Ghost? Think again. Introducing the all-new, better-than-ever Ghost 16. Now with nitrogen-infused cushioning for lightweight, supreme softness that feels good every step, every street, every single day. So go ahead, take your daily joyride in the all-new nitrogen-infused Ghost 16. It'll turn your everyday miles into everyday endorphins. Let's run there. Head to brooksrunning.com to learn more.
Yeah. I think that's part of the not understanding kind of the idea of high pivot on a shorter travel bike for a lot of us, myself included, which is that, and to make it work and to make it make sense, it sounds like you need to have this different placement of the pivot to make it all work. And you mentioned licensing this technology or this design from iTrack. Is this something that they developed for bikes, or was it for some other application?
I believe it was developed for bicycles. Yeah, you've seen it more recent, I think, with kind of the recent sort of buy-in back into high pivot bikes.
Okay.
There's a few other, I think Intense on their downhill bike at one point used this. There's a few other smaller manufacturers that are licensing it as well. Yeah, it doesn't really apply to all the other kinematics of the bike are our own. It's really just having the ability to do this. And when we recognized what a benefit it was, it just made sense that you'd strike a licensing agreement so that we could implement that on the production bikes.
Yeah. Well, so I'm curious. I haven't ridden the new Optic with the high pivot design, but from your perspective, from the people who test the bike and the people you've heard from since the bike's come out, did moving from a traditional setup to high pivot, did it change the ride feel of the Optic significantly, or is this more of kind of a minor improvement?
I kind of like to think of it like the Optic. I think it was really a category defining bike for us with the last generation, and that short travel, aggressive trail bike.
Yeah.
But I think a lot of that came from what we did with the geometry. And that bike predates me. So just kudos to the guys that worked on that bike and what they did with the geo, because I think it really did kind of define this aggressive short travel category. With the new bike, you'll see the geo really hasn't changed all that much. We felt like we were in a really good place for the intended use in terms of its geometry. But I kind of feel like the suspension had a ways to go to kind of match how capable the geometry was.
I see.
So on the last Optic, we really relied on air spring progression from the rear shock to get the support and that kind of poppy, playful feel out of it. So that shock was just jammed full of volume spacers. And that has some downsides when it comes to rebound control and what you can do with shock tune. So in addition to moving to this rearward axle path, high pivot layout, we also made some other changes that are a bit more subtle, but things like we moved to a slightly longer shock stroke that allowed us to lower leverage a little bit, but mainly to add progression to the bike. And by adding progression to the leverage curve, we could rely less on air spring. We didn't need to run as many volume spacers. We could tune the rebound around tracking, and it didn't have to control as much energy stored in that really progressive air spring. So there's a few things in addition to just the really obvious one of the bike having an idler and having some rearward axle path that we did to make sure that the suspension really kept up with what the geometry allowed the bike to do. So I think overall it's kept a lot of the characteristics that people really liked about the Optic, but it's meant that you can push it that much further. I really enjoy riding that bike.
Yeah. Well, looking at the Norco lineup, the Optic, it does have pretty similar travel numbers to the Fluid. And obviously, the geometry is a part of that. I mean, was moving to the high pivot meant to sort of distinguish it further from the Fluid, or like, how do you view those two bikes in terms of like how they're similar or how they're different from each other?
So the Fluid started as an aluminum bike, and then we also offer an option, the Fluid Carbon, which has a carbon front triangle. But to me, the Fluid in the design brief, it was really meant to be an all-arounder for your enthusiast mountain biker. Probably, some people are just kind of getting into mountain biking and want their first like proper full suspension bike. Some are just looking for a really killer value on an aluminum bike with good components. And really, I think in most cases, they either want it as their single bike that can do a bit of everything, or they want it as, a short travel bike to kind of complement a slightly longer enduro rig or something like that. So it's been, meant to be a bit more of an all-arounder, good for a range of different trails. The Optic is a bit more purposeful. It's really, we've just leaned into that aggressive short travel category that we kind of created with the previous generation. And to me, it's really a bike that the most fun times I've had on that bike is you ride through something and you're like, holy shit, I can't believe that I just rode through that on a 125 bike. Like you just forget it. It can get you in and out of trouble, and you'll ride, trails that you really shouldn't have any business riding on a bike of that travel. But at the same time, if you're going to ride, you want to ride jumps and corners, or, some like lower grade kind of flowy sections of trail. It's still really good on that stuff too. And that's kind of the magic of balancing the amount of rearward axle path that bike has with things like what we've done with the leverage curve and the geo, making sure that it still handles like a short travel trail bike should. And so that's kind of, I see how those two bikes differ. I know on paper, when you just look at travel numbers, they seem pretty similar, but when you dig into the details, they're actually fairly different.
Yeah. Well, still though, when you're describing the Optic, to me, it's like, it's an all-rounder too, right? Like we're saying, we can ride it anywhere, and it's, it's capable enough to do anything. I mean, it's tough. Like I think for core riders, it's pretty obvious like what that means. And obviously the Optic is, I think you're right that it's not for the enthusiast necessarily. It is for someone who is maybe a more experienced rider and is willing to like kind of challenge themselves a little bit more.
I think that's a good summary for sure.
So this decision though to use a high pivot on a short 125 millimeter travel bike is sort of a controversial one. I didn't know what word to use there. Like some people were upset, like honestly, about the bike because they love the Optic, and then to see this, what to some people, it seems like a very drastic change. Some of them were confused at a minimum, I guess. So why do you think this is? Like, what do you think it is that people are sort of reacting to about this change?
Yeah, I think it comes back to that sort of black and white way that high pivot bikes have been categorized up till now, where if it's got an idler, it's going to ride like this. And it's just meant to kind of plow through really chunky trails in a straight line, but it's not going to corner. It's not going to be particularly fun on smoother trails. Those are all kind of things I think generally that get associated with high pivot bikes. And so I think that's been something for us to kind of like break down some of those misconceptions and go, no, actually high pivot bikes aren't all created equal. Axle path is a spectrum. You can tune in a certain amount of rearward axle path to increase a bike's descending capabilities and also help with technical climbing to add. But at the same time, you can still make it fun to corner and ride jumps and just do all the things that you might want to do on a short travel trail bike. So it to me, it really is getting kind of the best of both worlds. I think, a lot of people come back to like, the idler's a trade-off that I don't need to make on a bike of this purpose. And at a certain point, I think that's true. Like, coming back to what the rearward axle path is supposed to do, if your terrain's just not rough enough to have a benefit, then, it's true. You probably don't need a rearward axle path and you don't need the idler that goes along with it. But, but I think just from testing that we did with these bikes early on, we sort of confirmed that in our minds anyway, that for the terrain that we see the Optic being designed around, there is still a benefit to having some rearward axle path. The bikes descend more confidently. You can winch your way up techie climbs more easily, but at the same time, we can keep the character of the original Optic. And so I think I totally get, people that haven't ridden the bikes and, have just seen sort of what high pivot bikes are generally associated with, being a bit confused by it. It really is, best understood through riding the bike. So, hopefully people that are a bit on the fence get a chance to demo one and kind of see what it's about. Because I ride kind of both the Sight and Optic back and forth, and they're distinctly different bikes and really enjoy riding each of them for the terrain that they're designed around.
Yeah. Well, I mean, this wouldn't be the first time too that people form opinions about a bike thing before they've actually tried it. So I guess we shouldn't be too surprised. So one of the promotional videos I saw for the bike mentioned that the latest Optic is lighter than the previous version. So that's interesting to me because, again, like just looking at these high pivot bikes, you assume like it's got extra hardware, so it must weigh more. So how much weight does the idler hardware and all of that actually add to the bike?
So in total, it's about 105 grams of weight that's added through idler, bearing, and idler bolts, and plastic guide, and a couple spacers.
Okay.
So there's really not that many additional parts. And we've offset some of that weight on the Optic by going to a full carbon back end. The previous generation of that bike had an aluminum back end. And the Sight, we've gone to a full carbon back end as well, where the previous generation had an aluminum chainstay. So frame weights are actually very comparable, despite adding a little bit of weight through idler.
I see.
And then obviously we've got aluminum versions of the Optic and Sight as well.
Yeah. And it sounds like there's not a lot of extra chain that you're adding here either. A standard chain is going to work on the Optic.
Yeah. That's true. There are a couple additional links in the chain. So not as many as on a bike like the Range. So the Range would run a full 126 link chain. The new Sights and Optics, depending on frame size, because we vary the rear center length, so your chain length changes a little bit, will be somewhere between 120 and 124 links.
Okay.
So slightly more than you might run on a bike without an idler, but not as much as the Range or even some other high pivot bikes where you have to link two chains together, which is definitely a pain.
Yeah. Right. Yeah. That's good if you can avoid that for sure. So I'm curious, what's next for high pivot mountain bike designs?
I guess I don't want to give all of our secrets away, but you're seeing, I think you're seeing, we've talked about them in the all mountain and trail space. We continue to believe that there's advantages to rearward axle path for those types of bikes. You're also seeing us with the development of the bike that the race team is on, working on something at kind of one extreme end of the spectrum. That's a different suspension layout. So that's a 6-link layout, but it also has an idler and also has a significant amount of rearward axle path. So you're going to continue to see us developing in that space. I think there's continued work to be done on drivetrain integration. I think we've made a lot of great steps towards having these bikes pedal, the same as a bike that doesn't run an idler, but there's always room for improvement there. And I think e-bikes are another interesting one. Like, to me, when we first talked about doing a high pivot like you see on our range and sight VLTs that launched earlier this year, I was a bit skeptical about it, because anytime that I've ridden a full power e-bike, a bike that's 55 pounds or so, the stability you get from that additional weight, especially, because it's part of what we call the sprung mass, so in the front triangle, just adds so much stability that I kind of question whether a high pivot would benefit those bikes. So we did some testing with that, and we ultimately said, no, you know what, there's actually still an advantage here. And I think the interesting thing that we're seeing now is e-bikes are getting lighter, and people are, demanding, they want the same torque and same battery capacity, same range, but they want those bikes to be closer to the weight of their pedal bikes, which I totally get. Like, they handle so much more intuitively when you can have a bike that's closer to a pedal bike weight. But what you lose in dropping that weight is the stability that comes along with, those 55 or 60 pound bikes and all that battery mass. And so I think it presents even more of a case for introducing some more rearward axle path on those e-bikes. And then when you think about it too, the downsides that people associate with high pivot bikes are less of an issue on e-bikes. The small inefficiencies that people might feel through the drivetrain just aren't really a concern when you have a motor. So that's another area where I see high pivot bikes going.
Interesting. Yeah. And I'm sure too, as we go on, we'll see these systems further optimized in terms of the kinematics and how it's all laid out and stuff. But yeah, it's really cool to see what Norco is doing in this area. And thanks for taking the time to talk to us about high pivot bikes and about the new Optic. Appreciate it.
Yeah, no problem. Thanks for giving me the time to talk to you about it, Jeff.
Awesome. Well, you can see the Norco Optic and learn more about some of the design involved at the Norco website, norco.com, and we'll have that link in the show notes. That's all we've got this week. We'll talk to you again next week.